All right, so this video is going to focus a lot on how do we draw organic molecules. Through general chemistry, you've generally depicted things in Lewis structures, which can be a little bit clunky, a little bit cumbersome to be able to draw. They take a lot of time. And organic chemists are a little bit lazy, and we streamline the process a lot, as you'll see in our second entry here. And the focus of this video is just kind of depicting a handful of different ways in which we can draw organic molecules. The very first actually predates Lewis. Auguste Kekule back in 1865 was one of the first to actually try to depict the structure of benzene. Benzene is going to be a structure that you're going to see a ton in organic chemistry. It is a six-membered ring where you have six carbons kind of bound in like a hexagon, and there's alternating single-double bond structures. Down below here, we actually have a kind of picture of like his original depiction here, and the story actually goes that he actually had a dream of a snake that was actually eating itself, and that's how the idea of these all being bound in a ring actually kind of came about. And it's actually decently accurate. So there's a lot of similarities between the Kekule and the Lewis structures. One of the main things is Lewis structures, you have to show all of your lone pairs and your formal charges. A lot of times lone pairs were omitted from, and formal charges were omitted. They also had really bad bond angles. But this was kind of like your original like idea of like what your organic molecules are. And the main one that you kind of see this for is benzene. And that's going to be, if we want to draw that maybe a little bit more, all of your carbons that are bound together. Each of these carbons are bound to a single hydrogen, and that would give 6 valence electrons to all the hydrogens. So therefore, if you just add double bonds at every other spot, that could be your structure of benzene. This is a solvent and a decent starting material that you'll see a ton, especially in organic chemistry too. Now, drawing this process takes a little bit of time because of how long and how many H's and stuff that you have to do. There's a kind of shorthand way that you can draw that, and that's actually known in our second one, which is our skeletal. The kind of shorthand way of actually drawing this, if we just kind of draw this down here, is actually just a structure like this. You can see how quickly we're able to draw that. This is like a six-membered ring with a circle in the middle. How much easier that is to draw than writing out 6 carbons, 6 hydrogens, and then drawing out 20-ish bonds or whatever. And this is the one that we'll spend the most amount of time on. It has a bunch of different names. Line angle formula is probably the most technical. Skeletal will be the one that I'll use kind of like the most. And then stick figures, I sometimes call them, because they're just a bunch of lines. This is kind of our shortcut approach, and it's a way to draw organic compounds really, really quickly. Most carbons and most hydrogens are not going to be drawn. They're going to just be assumed that they exist. So one of the trickiest parts is when you look at a structure, how can you like walk it backwards to see like where there are carbons and hydrogens in those specific spots. For these, anytime you have a line that ends or a change in directions for your line, a carbon exists at that spot, and we'll have an example of that just in a second. And then any hydrogens that are on carbons are not drawn. They're just assumed to be however many hydrogens are needed to get your full octet. Hydrogens on all other atoms must be shown. So if you have a hydrogen that's connected to an oxygen or a nitrogen, those must be shown. Hydrogen on carbons are omitted. So most carbons and most hydrogens are going to be not drawn in. Now to kind of show like an example here, here we have our molecular formula, C4H10. That doesn't show how many things are bonded. It just simply says, hey, you have 4 carbons and 10 hydrogens. There's a variety of different ways that you can connect these together, and those are all going to form constitutional isomers. That'll be something that we actually talk about in class. one of the ways in which we can connect this is all 4 carbons being directly connected to each other in a straight line. So this would be an example of like a Lewis structure, or a Kekulé for that matter, where you have all the 10 hydrogens on the outside. This would give you full octets and make everything happy. Our next thing we'll talk about is actually our condensed structure, and this CH3, CH2, CH2, CH3 is an example of a condensed structure. And then your line angle formula, or your skeletal structure, is this last one here. Overall, you see it's actually just 3 lines. This and this, the 2 red dots, are the end of a line, and that's actually corresponding to this carbon here and this carbon here on our original. And then let's maybe not do, let me do blue. At this point and this point, we get a change in directions, and those correspond to our inner carbons there. So overall, each of these dots are going to depict a carbon. So I have a carbon bonded to a carbon, bonded to a carbon, bonded to a carbon. And then there's a bunch of hydrogens here that are not shown because they're all connected to hydrogens. So rather than drawing that big complicated structure like you see like right here with your Lewis, you can draw this skeletal and do it a lot quicker and a lot easier. Similarly, and one of the things we'll get a ton of practice with in class is kind of like understanding what these kind of like look like. So for example, if I wanted to draw maybe a structure like this, this is way easier than drawing like what that Lewis structure would be. This Lewis structure would be a lot more complicated. We'd have 1, 2, 3, 4, 5, 6 carbons in our backbone. 1, 2, 3. On this one, we have an oxygen with a hydrogen. And then you have all of these different hydrogens that are going to exist on all of our carbons. So our structure here on the left is our Lewis structure, and then our structure on here on the right is our skeletal, or our line angle formula. And you see how easy that is to draw in just comparison, and how quickly it is to draw. And again, this carbon, those 4 in the middle are going to be here, 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 and here. The 2 on the ends are going to be at our ends here, and then our OH is drawn here. You do note that this hydrogen on our oxygen is drawn in because of the fact that that hydrogen is not connected to a carbon, so we do have to draw it. The other thing that is sometimes confusing for students is going to be this end right here. That end right there is not a carbon. That is a carbon bonded directly to the oxygen. You do have to show bonds. So a lot of times students will sometimes add an extra carbon there, which you can't. And we'll do some like practice on those in class. But in general, you're going to see a bunch of zigzags. Anytime you get a change in direction, that's a carbon. And then there are hydrogens that are assumed on all the different carbons. So in like the yellow spots, there is only 1 bond shown. So there needs to be 3 more bonds. So that means there are going to be 3 hydrogens. On the pink, that isn't the one with the OH, you'll see that there's 2 bonds shown. So that means there are 2 hydrogens. So there's a hydrogen here and a hydrogen here, which are omitted. The last is your condensed structure. And this is a way of depicting structures in text format. You'll see this a bunch in your textbook. It's pretty rare for me to kind of give you these on like problem sets or stuff, but like if you practice problems in the book, you'll see this structure a lot. And these are the way that you can kind of like type things out on a computer a lot easier rather than showing like actual like zigzags and structures. And that's like that third structure and the one up on top, that CH3, CH2, CH2, CH3. If you wanted to actually write out like a condensed structure for that structure that we drew up above with the alcohol, that's the OH. That could be CH3, which would be our yellow, CH2, CH, OH, CH2, CH2, CH3. This would be like a kind of like full written out structure. Anytime you have brackets, brackets are going to mean this entire thing is actually also connected to the carbon. you'll get a lot more brackets, and these can kind of be a little bit more confusing. But we'll get a little bit more practice in class and stuff like that. And these are our kind of three main ways in which we can draw structures. Our Lewis and our Kakule, which are kind of our original ways that are kind of a little bit more cumbersome. Our skeletal formula, our skeletal line angle formula, our stick figures are going to be our most common. And these are going to be zigzags where we have a bunch of carbons and hydrogens that are just kind of understood to be there. And then you'll have your kind of like textbook way. So we'll go and stop there and then get a bunch of practice in class.